Welcome back, chemistry students. Last time we were talking about oxidation reduction reactions. We're going to continue on with oxidation reduction reactions. What we're going to learn about today is balancing them. If you haven't copied down this diagram yet, make sure you do so because you'll get to use this on the test. It's a long, complicated process on how we're going to balance these things. We are going to go through this step by step. I'll run through this example and another one in this video. But yes, if you haven't done so already, make sure maybe stop this video and write this diagram down. You can find it in Schoology. So yeah, let's get this thing started. I have an example on the board here. So this is a oxidation reduction reaction. We're going to balance this thing. Step 1 on the diagram says to write separate half reactions. So what we need to do is we're going to write the reduction half reaction and the oxidation half reaction. So I'm going to do that now. So I have this is going to be one of the half reactions because the ions are going to go together, and then these ones are going to go together. So it's pretty easy to identify your half reactions. So these go together, then these go together. So we got Mn O4 minus goes to Mn plus 2. So one's going to be an oxidation half, one's going to be a reduction half. At this point, it doesn't really matter if we identify which is which. It's just that we break this down into the two half reactions. One's going to be an oxidation half, one's going to be a reduction half. At this point, it really doesn't matter, okay? All right, so that's step 1. So split it apart. Then what we're going to do is we're going to balance each half reaction separately. And this is the balancing order that we're going to use. We're going to balance the elements, okay, first, other than like hydrogens and oxygens. Then you'll balance the oxygens next using water. Then you'll balance the hydrogens out with H pluses. And then we'll take care of the charge using electrons in the end. So let me show you the balancing order. Let's look at the iron one. So if I'm going through the order, it says balance elements except for hydrogen and oxygen. Well, I have one iron. So that's good to go. Balance oxygens. Well, there's no oxygens to balance, so we're good. Letter C, hydrogens, nothing. Letter D, balance the charge using electrons. So here I have a +2 charge, and on this side I have a +3 charge. So what I'm going to do is I'm going to add 1 electron to this side. And what that's going to do is that's going to take, and when you add this to this, it's going to give you a +2 charge. So now the charges are balanced. So that half reaction is good to go. So let's balance this one. All right, going through the balancing order, doing the elements. Well, they're good. Okay, Mn and Mn's good. Now let's look at the oxygens. We have 4 oxygens on this side. We do not have 4 oxygens on this side. So what we're going to do is we're going to use water. So I'm going to add 4 H2Os on this side. So then what that does is it gives me the 4 oxygens that I'm going to need. Okay, then the next step, use the hydrogens. Okay, so I have 8 hydrogens on this side. So I need to go plus 8 H pluses over here. Okay, and then the last thing I'm going to do is I'm going to balance the charge using the electrons. All right, on this side, I have a +2 charge, and then this is a 0 because it's a neutral compound. So over here, it's a +2 charge. On this side, it's going to be a +8, but then -1 will give me an overall of +7. So in my brain, I'm going, okay, over here, this is a +7. Over here, it's a +2 charge. I need to make sure that the charges are the same on each side. So what I'm going to do is I'm going to add 5 electrons. And I'll let you think about why I added the 5 electrons. Hopefully you're reasoning through here and going, oh, I'm adding 5 electrons because that'll bring this overall charge down, and then you'd be correct. Okay, so now we're here on the flow chart. So we balanced each half reaction. Then what we're going to do is we're going to equalize the electrons transferred. So over here I have 1 electron that's being transferred, and over here I got 5. But we have to balance that out, so here's what we're gonna do. We're gonna multiply this guy by 5, and it's multiply the whole thing by 5. So now I'll have 5 irons goes to 5 of these plus 5 electrons, okay? When I multiply it, I cross it off. That way I don't get confused, okay? I've changed it, so I'm just gonna cross it off. Now this one's got the 5 electrons, so we'll be good to go, okay? Then we're gonna add them together, and then it says cancel identical species. So canceling the identical species, what that means is we can cross off species that appear on both sides. So with this example, the electrons cancel out, okay? So then what you do is just a simple math problem, is you add it all together. So 8H plus MnO4 minus, and I cross them off as I go, plus 5Fe plus 2. So I'm basically adding this back together. What you're doing is you're recombining those 2 half reactions. So I'm adding this to this, okay? So then I got 5Fe plus 3 plus the Mn plus 2 plus the 4 H2Os. All right, and if you were to go through and double check it, you'd see it works out. 8 hydrogens, 8 hydrogens. 1 manganese, 1 manganese. We got 4 oxygens, 4 oxygens. 5 irons, 5 irons. So that's cool, it worked out, it's balanced. But now we have to consider the charge too. So over here, you got a coefficient in front. This would be like 5 times 2, which would give you your plus 10 here. So this is plus 10. Then you got the 8 pluses here, so now you're at 18. Minus 1 would be at the 17. Let's double check over here. I got 5 times the 3 is 15, plus 2 more makes it plus 17, it worked out. So not only are the charges balanced, but all the elements are charged. So that's what it says here. Check that the elements and the charges are balanced. So it's a process, but this would be the final answer. And it is a process, that's why I'm letting you guys use the flow chart on the test. So make sure you guys got this. Let's do another one so you guys see a different example. Once you get the hang of it, these problems are pretty fun to do. You just got to be careful at every step. All right, so let's look at, let's see here. Let's find a different one here. Yeah, let's go with this one. All right, so I got okay, so that's what we're going to be balancing. So the first thing that we should do is, like it says there, is write the separate half reactions. So hopefully you guys can see that this goes together with that. So I'm going to write this as a half reaction. And this goes together with this. So I'm going to leave myself some room because, you know, we have to do some work to it. Okay, so those are the 2 half reactions. So we've separated it. The next step is we're going to balance each half reaction. Here's the balancing order. Balance elements, and then take care of oxygens, hydrogens, and charge. So over here, the first one, I'm going to balance the elements first. This one actually applies because you got 2 arsenics here and only 1. So I'm going to start by putting a 2 in front, and that's going to balance out the elements. The next one says balance oxygens, and we're going to do that using waters. Okay, so I got 8 oxygens here. Over here I have 3, so I need to add 5 H2Os to this side. Now the oxygens are balanced. Okay, the next step, balance hydrogens using H pluses. Okay, so I got 10 hydrogens here. I got 6 hydrogens here. So I need to add 4 H pluses to this side. Okay, we're getting closer. The next step is balance charge using electrons. So over here it's 0 and 0. This one's pretty easy. This is 0. So I need to make this 0, so I'm going to add the 4 electrons, so these essentially cancel out. Alright, so this half reaction is ready to roll. Now let's balance this half reaction. Here's our order. Elements, and then go oxygens, hydrogens, and the charge. Well, I got one element, nitrogens, good to go. I can see I have oxygens to take care of, so I'm going to add 2 H2Os. Then it's kind of fun. Oh, hey, I just introduced hydrogens. Jump over here, add 4 H pluses. Okay. Then the next step is the charge. Okay, over here it's 0 and 0, so that's pretty simple. But on this side you have 4 pluses with this negative, so in your brain you should see that this is a +3, and on this side it's a 0. So I need to bring down this to a 0, so I'm going to add 3 electrons. Okay. All right, this is the real fun one because, well, so they're ready to go. We balanced them. The next step is equalize electrons transferred. Well, with this one, I got 3 electrons that are being transferred here and 4 over here. So you might guess that, oh, I have to equalize those out, so I'm going to have to multiply them to get a common multiple of 12. And you'd be right. So I'm going to multiply this one by 3. I'm going to multiply this whole thing by 4. So I'm going to go 15 H2Os plus 3. And this is where mistakes happen, is when you're not careful about multiplying everything, or if you don't copy it down right. So if you're making mistakes on these problems, it's probably not because you're not understanding it. It's because we're making simple mistakes. And then I cross that off so it's done with. I'll go like this. So the problems aren't too bad. You just really need to take your time and make sure you're copying and transferring the information down, and then you'll be fine. And then you can always double check yourself in the end, so you can see where you kind of went wrong. All right, so now I've changed them both. The next step is we're going to add this to this, right, and get one new equation. What we're going to do is we're going to cancel out those identical species first. So, okay, electrons gone. Those are on opposite sides there. This is a different type of problem. This is a good one to see. I have 16 H pluses here, and I got 12 over here. Well, guess what? All 12 of these will disappear, and then the 16 will now be a 4 because the 12 will disappear from there. Okay, we're almost done. I see another like species, which will be right here. All 8 hydrogens are going to go away here, and then this will now become a 7. Now I'm ready to add it together. So I got 7H2O plus 3AS2O3, and then I cross this stuff off as I go, because this could be an area where you might make a mistake. So I make sure that after I've transferred it down, I've canceled it out. So just some tips as you guys are working through these problems. Just kind of go carefully, and you should be good to go. All right. Okay, nothing's been missed. So now what I'm going to do is I'm going to double check, right? I'm going to check that the elements and the charges are balanced. So I'm going to start with my elements. I got 14 hydrogens here. On this side, I got 6 times 3, which means 18. Let's see here. So, oh, I know why. I was just going to say, I crossed this off, but I did not transfer these down. So what I need to do is add the 4 hydrogens. So there's a mistake that I caught just by double checking myself. Because there I was like, hey, hydrogens aren't adding up. So here is 14 hydrogens. On this side it's 18. But hey, here's 14 plus the 4 that I missed, right? So hey, now I got 18. I'm good to go. Okay, so now let's figure out the oxygens. Here I got 7 plus 9 makes 15. Plus another 12 makes 27. Then on this side I got 6 times 4 is 24, plus 4 more makes 28. I'm going to double check this. Let's see here. So 7, 9, 16. Okay, I do have 28 oxygens there. Let's double check the arsenics. I got 6. And then on this side I have 6. I'm good there. The last thing I have to double check is the nitrogen. So there's 4 nitrogens, there's 4 nitrogens. So I'm going to be balanced. It worked out. So this would be my answer. All right, so you guys will have a review packet on Schoology. There will be a couple problems like this that you guys will have to try to do, and there will be 2 of these balancing on the test. In Schoology, I have you guys kind of filling in the blanks. So, but yes, feel free to reach out to me if you guys have any questions on this. You do get to use the flow chart, so maybe take some time to study this and see if you have any questions on the flow chart. So, all right, we'll see you guys next time.